Alright, so I'm gonna pick up from where we left off yesterday in lecture. If you remember, if you read the review, you remember that we kind of got stuck on this problem here and why the substituents were all pointing down. What I did was I got home, I found my molecular model kit, and I just assembled them like the reaction called for it. So if you have a model at home lying around somewhere, definitely take it and set it up like the photos. If you don't, it's okay because I've put some of the examples on the lecture notes, which I'm going to upload to Blackboard after. Hopefully with these photographs of the models, you would be able to see why the substituents end up where they end up being. And yeah, so I'm going to start explaining it step by step. Hopefully you will be able to follow along. You can always slow it down. That's a good thing about YouTube videos. And yeah, so just follow me really, really carefully, and hopefully we will get to the same place. Okay, so where we started off was that this diene and dienophile are going to go through a Diels-Alder reaction under heat conditions to form a cycloalkene. We have a methyl on the first and the fourth carbon, and then on the fifth carbon, we have a cyanide group. Now, we don't know what the stereochemistry of each of these substituents are, so we're going to have to determine if each of them is a wedge or a dash. Okay, so we don't know yet, and that's what we're here to figure out. Now, remember when we started off drawing the reaction mechanism, we had methyl pointing out at me, so the methyl that's right here is pointing out, and there's another methyl right here that's also pointing out. So methyl, methyl. I'm gonna color this methyl yellow right here so that you can follow as I go along. So we have a methyl. This is the yellow one, and we have the red methyl right here. Then our double bonds, if you can look at the structure of the diene, is that there I have two double bonds. I have a double bond here and I have a double bond here. This is my single bond, and that's basically your diene. A 1,4 substituted diene rather. As for the dienophile, this is the double bond with the blue ball being right here. This blue ball that I'm shading in blue is my cyanide group, where it's going to come from below. And what's happening is now I'm gonna combine these two together. So this carbon right here is gonna make a bond with this carbon. This carbon right here is gonna make a bond with this carbon. And what we have is this right here. Just rotate this. Hopefully it'll be better. There we go. And of course, because it's a transition state, everything here becomes a dotted line as well, until they are being formed into a solid bond, which is the second photograph. Let me just redraw. Oops. Just redraw these bonds here, make them a little bit longer. Okay, now, if you compare this drawing with the photograph, you're gonna see that this and this right here correspond to these 4 lines, the one in yellow. And then the part that I put in red, which was your dienophile, carrying your nitrile group, is right here. It's forming one bond here, one bond here. And then my nitrile group does not change. Still right there. let's take a look at our substituents now. We have our yellow methyl group, which is still pointing out at us. And the other red methyl group, right here, is also pointing out, which means that these two non-filled bonds right here are going to be your implicit hydrogens. If I draw them right here, you will see that this is hydrogen right here. This is what it pretty much looks like. So now we are going to have to convert them into a chair conformation. Hopefully you're still with me. Almost there. And what we're going to do is that because these two carbons right here, if you follow the green highlighter, this carbon and this carbon currently are pointing at the same face. So they're pointing up. To make a chair conformation, we got to make one of them point down. And the easier one to make it point down would be the one at the back. So I'm going to change this direction. I'm going to make this carbon face downwards to make a chair. In doing so, I get this. I get a chair conformation, and this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. My numbering can be arbitrary, so why not just make this carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Now, carbon 1 has a methyl that's pointing up. But because we are pushing this bond in green right here, we're pushing it down, so it will be flipped the other way down. So it's gonna end up being down. And this is our red methyl group. For our yellow methyl, it's at carbon 4, which is also pointing down. And for carbon, we have at carbon 3 the cyanide group, which we know because it's facing inwards, it's gonna end up pointing down. And this is why, if you see the way that they're arranged, this is pointing down, the yellow methyl is also down, the cyanide is also down, which means that this is a syn-substituted molecule. And therefore, when we combine everything, we can finally draw our final product, which is everything facing down on the same side, plus the enantiomer. And then this would therefore be our final answer. Hopefully, the photographs and the molecular model kits do help in helping you see the molecule substituents a little bit better. If you still can't identify the chair in the photograph, I'm gonna go ahead and mark out where the chair is. So this is the chair right here. 1, 2, 3, 4, 5, 6. This is my chair, and we can see that the methyl group, when you rotate the bond, ends up being at the bottom. This yellow methyl ends up also being at the bottom, and the cyanide group ends up being at the bottom. So with that being said, if we had a reaction where my diene is substituted 1 in, 1 out with the same thing right here, we know that one of them is going to be anti. The one that's going to be anti would be the methyl, because now they are, one is wedge, one is a dash, and then my cyanide group is going to end up being on the same plane. And there you have it. Alright then, I'll see you guys in the next video.